Welcome to part 2 of our two-part video on basic maths and operators. So if you remember the objective slide from the last video, we have a couple of them left to address in this video. One of those is to look again at the much neglected Boolean data type, and that's something I promised I would do in the very first video in the series on data types. BIDMAS is a quickie because Python uses the same prioritization of maths operators as you do in your maths. So the mainstay of this video really is the comparison operators, which will be the precursor to a much bigger topic that I will cover in the videos, and it's a much bigger topic in programming in general. And this is the testing of conditions to see if they give us a true or a false value, and sequencing our code to allow for appropriate selections to be made in the program. And it's important to remember, guys, that our algorithms to solve problems or to complete a complex task will naturally include the need to test conditions and to make appropriate selections. So an example would be a recipe for cooking, which is technically an algorithm, where we would say, has the cake been in the oven for 40 minutes? If true, remove from the oven and cool. If false, then leave in the oven to cook for longer. Now we need to reflect similar requirements when we turn an algorithm like this into a programming language like Python. So let's crack on and do some Python demos. So before I launch into the world of BIDMAS and comparison operators, I just wanted to revisit the math library which we imported and used in part 1 of this two-part video. So if you remember, I had 3 choices and I chose the one which would allow me to import all of the functions from the math library, which I could then use in my program. And the syntax for that was to say import math, so that's the name of the library as, and then I gave it a nickname that I could refer to in my code as MT. So having done that, I do as a precursor, I do MT dot, and when I put the dot in, PyCharm intelligently produces a list of all of the mathematical constants and functions that are available to me now that I've imported everything from the library. So some of these you'll recognize instantly. So here is pi, for example. So rather than looking up pi or trying to remember that it's 22/7, if I'm using the math library, I can just use the mathematical constant by pulling it in from the library. So that will be mt.pi will give me the value of pi, which is already there in the library. Okay, really useful. Where you see the pink circle with f in, that stands for function. So all of these are functions. Pi, of course, has got a marker or a flag that says v, and that of course stands for variable, because as you know, Python doesn't have constants. So normally that should say c for constant. Okay, so if I scroll down, you can see that there are literally dozens and dozens of mathematical related constants. Okay, so there's the constant e, and also dozens and dozens of maths related functions as well. So quite a lot of those are trig related functions because there's a lot of them. They're the trig and the inverse trig functions as well. You can see here that we have a series of functions which allow us to do maths with logs. Okay, so logs to the base 10, for example. What others might you recognize? Let's have a look. So we have a function which will enable us to work with factorials. We have a function which will allow us to work with exponents or exponentials. We have a function which will enable us to work with degrees, and I think there's also one that enables us to work with radians as well. Yes, there it is down there towards the bottom. Okay, so now you've seen all of these, I don't want you to panic and think that you need to know these, okay, or need to be familiar with them, because it's not going to be the case on a GCSE computer science course, guys, that you're going to be tested on your knowledge and skills of GCSE maths. So you're not going to get a programming challenge asking you to calculate the angle given two sides of a triangle using tan, inverse tan, and then converting radians to degrees or anything like that. But I wanted to show you this because if you like maths and if you like programming, then not to make you aware that there's all of this amazing stuff available in the math library that you can use actually feels a bit unfair. So there are other Python math related libraries as well which you can research on the internet. NumPy or NumPy is one of them. You've got SciPy, as well. So there are all sorts of things, additional bolt-ons if you like, which make Python a very powerful mathematical related programming language. And if you're interested and motivated, you can do a little bit of research and trying out some code in your own time. So let's have a quick look at BIDMAS. It's going to be quite short because essentially Python does exactly the same as you guys do in maths. Okay, you call it BIDMAS, which essentially is your acronym for remembering the priority or the hierarchy of mathematical operators. So brackets first, followed by indices, divide, multiply, add and subtract, reflects the hierarchy that you use in maths, and Python does exactly the same. So to give you an example of this, let's just clear that. Okay, there we go. So to give you an example, let's do print 3 plus 8 multiplied by 10. So you would expect, using BIDMAS, for the 8 times 10 evaluated as 80, added to 3 would give us 83. So let's check that Python is doing exactly the same thing as we would do. So there you go, 83 is the answer. If of course I decide to change this by putting brackets in around the 3 plus the 8, I'm going to get 110 this time, because I prioritize the 3 plus 8 as 11 multiplied by 10. On this occasion will give me 111. So let's just run that and make sure that we get the same thing. There we go. Okay, so really there's not much more to add, because essentially you create your Python expression in exactly the same way as if you were in a maths lesson. What I would say, guys, though, is that Python will allow you to put in place redundant brackets. Okay, and redundant brackets are really useful just to make your expression look a little bit neater. So to give an example, if we are evaluating the expression minus 1, let's not do minus 1, let's do minus 7 multiplied by 8 plus 6 divided by minus 7. Okay, so as well as putting brackets around this just to tidy it up a little bit, just to confirm, okay, the way that expression is going to be evaluated, the brackets I've just put in are redundant, because you're going to get the same answer with or without those brackets. Okay, but putting the brackets in place also makes the code or the evaluation expression look a little bit neater. The other thing you might want to do, let's take those brackets out, is you might say, actually my code would look neater if I just put brackets around the negated numbers. So minus 7 multiplied by 8 and then 6 divided by minus 7, like this. Okay, so I know that when I studied maths at school, I was always told to put brackets around negative numbers because it just makes it easier to understand what's going on. Okay, if you feel that's the same in your programming, then do that as well, guys, but the choice is yours, because redundant brackets are catered for and it won't cause a syntax error. So let's launch into the world of comparison operators. On the screen you will see a table of the symbols that Python uses as comparison operators, so the ability to be able to compare one value with another value. And as you can see, guys, there's nothing on the screen there which will come as a surprise, because you have been using something very similar in your maths for many years. So the other type of comparison which I wanted to cover in this video, you will see now at the bottom of the table. Don't worry about those for the moment, because obviously I will be exploring the significance of those later on in the video. But if you did just want to take some time to read what it says at the bottom of the table, you will be prepared for what is to come a little bit later on. So let's just jump straight in with one line of code, and it says print the result of 4 is less than 10. And if we run that one line of code, we get the answer true. And you will remember, guys, I'm sure, that true with a capital letter is essentially a Boolean data type. So Python, whatever it's done with this evaluation, this expression that we want evaluated, has returned and told us that the answer is true as a Boolean data type. So what's actually going on here? Let's just get rid of those boxes. Let's do what we always do. Let's start off right in the middle of the brackets. 4 is less than 10. We're essentially asking Python to tell us whether it is true or false that 4 is less than 10. Clearly 4 is less than 10, so it returns the answer true. Let's look at another example where we tweak the code a little bit. Let's put in 4 is less than or equal to 4. Clearly the answer to that is for less than or equal to 4, true or false. Clearly the answer is true. So let's run the code and see what we get. And indeed we get true. Let's do another one where we generate a false Boolean data type. So let's do 40 is less than or equal to 4. So let's run that and see what we get. So on this occasion, evaluating that expression, or asking Python to evaluate whether that expression is true or false, Python tells us that it is false. 40 is not less than or equal to 4. Let's look at perhaps an even more obvious one. Let's do 10 is equal to 10. So asking Python to tell us, is 10 equal to, or does it equate to 10? So let's run that and see what we get. No surprises really. Clearly that's true. Let's see what happens if we say, is 10 greater than 10? So clearly it isn't, so we get false. Let's do one more because I think you're getting the gist of this. Print, let's say 100 greater than or equal to, less than or equal to 10. Let's run that, see what we get. Okay, no surprises guys, we get false. So far we have just printed out straight to screen the result of the evaluation. But of course what we can also do is we can assign, or ask Python to assign the results of evaluating a true or a false condition and pop that into a variable. So you can see here I'm asking Python to evaluate whether or not 4 is less than or equal to 10, and then to assign that to a variable myval. And of course, what data type, guys, will the assignment be? It will be a Boolean data type, either true or false. So let's run that and see what we get. Oops. If you're wondering why I've got the input there, it's just so that the screen doesn't fill up with other bits of code, which I will show you a little bit later on. Okay, so myval has been assigned the value of true, which is a Boolean data type, and when we ask Python to print out myval, it prints out the value that's been assigned, which is true. Let's just change this again to show that it works either way. So let's run this. Okay, so obviously 40 is not less than or equal to 10, so the Boolean data type that's been assigned to myval has the value of false. When we print it prints out false on the screen. So before we move on to how Python evaluates a value against a range, I just want to show you this it's quite a useful Python feature which enables you to negate a pre-evaluated true or false. And essentially all we do, if we want the opposite of what's being evaluated, we simply pop in the keyword not. So in this example we used before, if I run that, okay, we are clearly going to get the result of false. If I wanted to negate that, what I can do here is I can put in myval equals not the result of the evaluation of 40 less than or equal to 10. Now, if that looks a little bit weird and you're asking why would you want to do this, it is quite useful. We will be using it in future videos, but to leave it out when we're talking about conditions and selection is probably not a good idea. So I want to include it as part of the overall topic. So if we run this, we had false last time, and this time we get true. So we can use this negating concept in different places in our code. So here I've popped it at the top where I said myval is not, or the opposite of however 40 and 10 are evaluated, being compared with each other. What I could do, if I put that back the way it was, I could say myval becomes not myval. So I could pop it there as well. Let's do it again. Make sure it runs okay. There we go, and again we get true. Okay, so I just wanted to make you aware that this little feature works so that we can include it as part of the thinking and scope of this particular topic. So let's look at one of the ways in which Python will allow us to test a condition for true or false against a range of possibilities. So if you have a look on the slide, in the green box is a mathematical expression which you may be familiar with from your GCSE maths, but it's quite a common way of expressing a range of numbers. So to see how this works, let's put one of those numbers in the top list, let's say number 4. Let's put that into the expression. We replace n with the integer 4, and let's see if this works. We start off on the left hand side and we say, is 0 less than or equal to 4? That's true. But is 4 also less than or equal to 10? That's true. So 4 is included in the range of valid numbers given by the expression in the box. Let's test 0. So we replace n with 0. Is 0 less than or equal to 0? That's true. Is it also true that 0 is less than or equal to 10? That's true as well. So we've got a true on both sides of the test. So 0 is valid. Let's take 10 at the other extreme, pop that in and replace n with the integer 10. Is 0 less than or equal to 10? That's true. But is 10 also less than or equal to 10? That's true as well. So 10 is included as a valid number given by the expression in the box. So the expression in the box will allow us essentially to generate a sequence of integers from 0 to 10 inclusive. So that's one of the mathematical ways of expressing a range of numbers. So let's test a couple of numbers which we know are outside the range for n and see what happens if we replace n with one of those numbers. So let's try -1. So let's replace n with -1. Is 0 less than or equal to -1? That's false, so we can stop there. We don't need to go to the right hand side test. What about 100? Let's replace n with 100. Is 0 less than or equal to 100? Well, that's true, but what about 100 less than or equal to 10? Well, that's false. We need to have two trues. So because we've got a false there, 100 is excluded. Okay, it doesn't agree with the conditions for this range of numbers. Okay, so in Python we can express exactly the same syntax to do a true or false evaluation. So let's see how that works on the screen. So let's have a look at exactly the same expression which I've put into the Python code. I've just jazzed up my printout with some extra formatting. So let's see how this works. You can see if I run this, it says true for n equals 4. So exactly the same type of test we were doing on the same expression that you saw on the slide. So how does this work then? Well, let's do what we normally do. Let's start off on the right hand side. Okay, to get the value of 4, I've taken the integer value and I've cast it to a string so that I can include that as part of my concatenation. Hence, it appears here as 4. Okay. This bit here, this is basically just a literal string value I've put in for my formatting. So that is included here. So that's cool because that's a string in the first place. This is the expression that's evaluated, and it's exactly the same as you saw on the slide. We're asking Python to say if two conditions are true. Is it true that 0 is less than or equal to 4? That's true, and 4 is also less than or equal to 10. So Python returns the value of true, okay, which is essentially here. But in order to concatenate that as part of my formatting, of course, I need to cast it to a string data type, because at the moment true is not a string. We can't concatenate it. It's a Boolean data type. So just like the previous examples you've seen where we've had to cast a float or an integer to a string type for concatenation, I've had to do exactly the same thing for a Boolean. Okay, so that is how this formatting works, but you can also see that Python uses exactly the same syntax as that common mathematical expression for a range of numbers. Okay, so just to show you that this does work, let's look at one of those values which we said earlier on the slide was outside the agreed range. So let's do -1. Okay, let's run this and see what we get. So now we have false for n equals -1 for the reasons and the process that I went through with you on the slide. Let's try another one. Let's try 100, which we also know was false when we tried this out on the slide. So let's n equals 100. Let's run that and make sure that we get the expected result. And there again, guys, you can see that we do indeed get false, because 100 is not in agreement with our expression 0 less than or equal to n less than or equal to 10. So before we wrap up with this video, there is a little bit more that I wanted to do to cover off on the Boolean data type, but I also wanted to squeeze into this video Python using the in-range feature, or Python enabling you to use the in-range feature, mainly because it tends to get forgotten about in this topic. So strictly speaking, this isn't really about conditional operators, because you won't see a conditional operator in the syntax. Essentially what we're doing, however, is we are asking Python to take a value and to compare it with the values in an existing list. If it finds it in that list, then it will return the Boolean data type with the value of true. If it's not in that list or collection, then it will return the value of false. So the reason I've included it is because you still get a true or false evaluation, but strictly speaking, it's not really about comparison operators. It does tend to get forgotten about, though, for that very reason. So it's a very, very useful feature of Python. And you'll also notice, guys, evidence yet again of how flexible Python is. In here, you can see that I have multiple data types. So it's not just a list of numbers or a list of strings. It's a list of anything you want it to be. So testing to see if a value you provide is part of an existing collection or list is very, very powerful. And I'm popping it here so that you know that it's available and part of the thinking about evaluating for true or false. So finally, guys, to wrap up this video, I just wanted to revisit the Boolean data type, and just to make you aware that we can think about the Boolean data type in ways which aren't just about yes or no or true or false. So you've got already that when we typically tend to answer a question as yes or no, one or the other, when we're doing programming, we tend to switch that around and we talk about true and false instead of yes or no. But there are other ways of thinking about the Boolean data type which goes beyond the yes and no and true and false. So I just wanted, there's no code to run here, just wanted to make you aware that we can actually use the Boolean to express different concepts as well. So at the top here, guys, what you've already seen is that essentially we can express true as yes, and we can express false as no, and you've seen that already. What we can also do, however, is we can use a Boolean as part of a control system. So for example, we could think about true as being a value to represent something being switched on or turned on, okay, and likewise false would be the opposite of that, which is part of our system which is switched off, okay. Likewise, guys, we could think about using the Boolean data type to represent flagged data from a database. So if an item of data is flagged, then we can associate flagged with true, and likewise false would then be not flagged, okay. Some other examples: in an object system with behaviors, we could assign we could assign a Boolean to one of two conditions. So for example, if we assign something as moving, or an object as moving, as being true, then false would represent that object in its stationary state. Likewise, in science, we could perhaps use a Boolean to express a state which is either stable or non-stable, okay. So stable equals true, therefore if the value is false, then that would represent a concept of it being unstable. In statistics, we could use true to represent a significant and false to represent non-significant statistics. And then in maths as well, with sets, subsets and members of sets or groupings, okay, we could express true as being numbers which are, or a group which is a subset of another group, okay, so inclusive. Conversely, if it's false, then the numbers or that group is not part of some other group, okay. So just wanted to express different ways, or a broader way of thinking about true and false and yes and no. Okay guys, so that brings us to the end of these two videos. I hope they have been useful for you, and in the next video we will be looking specifically at div and mod, the features of arithmetic operators, which I said deserved a little mini topic on their own. So I will see you in the next video.